Right, so this is finding the zeros of a polynomial. So how we're going to start this is we're first going to use synthetic division with some zero that we already know, and then find the others. So right now we know that 3 is most likely a 0. So if we take and plug in 3, it's nice that they gave it to us, right? Oops. And we plug that in, it does give us 0, so that we know it's a 0. But another way to verify this is to use your calculator. So I've already plugged it in, sort of. I made a little mistake right here, so let's do second, insert an x. Let's move it back. Let's just put in an x plus 6, and that is our polynomial, right? X cubed minus 2x squared minus 5x plus 6. Back to the calculator. And there it is. And so if you remember, we just hit zoom 6 to get our basic graph. And you can see that it's crossing at 0, but just to verify it, we hit trace, and then we plug in 3 and hit enter, and it says it is a 0. So we know 3 is a 0. We also know 1's a 0 and negative 2. So we already know our zeros. We just have to find them mathematically. You can also use the graphing calculator Desmos, right? By plugging it in there, you can see there's all your zeros. So look, negative 3 is a 0. So we have established that 3 is a 0. So now what we're going to do is find the rest of the zeros. Okay? So how do you do that? Well, we first start by using the remainder theorem. If we know that by plugging in 3 to remainder, we're going to get 0. So we take 3 and we divide it. So what we're going to do is take that polynomial, x cubed minus 2x squared minus 5x plus 6, and divide it by x minus 3. And this is because we already know 3 is a 0. So by doing this, we are going to remove this as a factor, leaving us with only the other 2. So 1, negative 2, negative 5, and 6. And by using the remainder theorem, we know that if we divide this by x minus 3, we know our remainder will be 0, because that's what we got by plugging in 0, which means it's a perfect factor. Okay, so let's finish this. 1, so that'd be 3, that's 1, that's 3, it's negative 2, it's negative 6, and look at that, 0, just like we wanted. So what that means is we're left with x squared plus x minus 2. So we have now taken our polynomial, and by dividing it by x minus 3, we are left with this. So what we have basically done is taken our polynomial, let's write it down here, and broken it into x squared plus x minus 2 and x minus 3. So now all we're left with is this, and that's our other 2 zeros. So if you look here, there they are, negative 2 and 1. So all we need to do now is to find our 2 zeros from here. And you can use quadratic formula or you can use factoring. So we're going to do both. If you factor this, you get x plus 2 and x minus 1. And then we just bring that one down, which gives us our zeros of x equals, put them in order, negative 2, 1, and 3. And if you're not that great with factoring, we just use quadratic formula on that last little polynomial that we're creating here. So it's a nice clean step. Once you find 1 0, you use it, exact same number. If it's 3, we put 3 and we do synthetic, which then gives us our quadratic. And you can either factor the quadratic or you can use quadratic formula. So this would be negative 1 plus or minus 1 squared minus 4 times 1. I'm not writing out a, b, and c because I'm assuming you're good at this now. And then we work on the radical. So that would be 1 plus 8, which is square root of 9, which is 3. So putting that back in. And then we split. So we have negative 1 plus 3 over 2. And negative 1 minus 3 over 2. Which gives us 2 over 2, which is 1. And then negative 4 over 2, which is negative 2. And there you go. There's the other 2. So these are the steps that you're going to be using. You're going to take 1 0 that you do know, use synthetic division to break down our cube to a square, and then use quadratic formula on it. Now, what if one of the zeros is imaginary? Well, then you do the exact same thing. So if you think about it, we've got a degree 4. And in order to use quadratics, we need x squared with some stuff. And then we can use factoring or whatever else we need to do. But that means we need to remove 2 of these. And if you remember, we talked about this earlier. If 2 plus I is a 0, then we also know that 2 minus I is a 0, because these are nice rational coefficients. There are no i's in here. So if we have a 2 plus I, we'd have to have its conjugate in order to cancel it. So we take our 2 plus I, and we're going to use synthetic division on it. And it's going to be horrible. Just go with the flow. But the first step is always bad. Second step will be easier. So first we're going to start with the 2 plus I. And you're going to have to be very organized here. So we bring down the 1. And then 2 plus I times 1 is 2 plus I. And so I like to put little dotted lines here, because on each one you're going to have a real part and an imaginary part, just to keep it organized. And you can even take the imaginary part and put it in a different color so that it works. So negative 4 plus 2 would be negative 2. And then we put plus I. Oops, wrong color there. All right, so now what we're going to have to do is take that 2 plus I and multiply it to negative 2 plus I. So this would be negative 4, right? And then plus 2I minus 2I plus I squared. This is already difference of squares. Those cancel. So we get negative 4 plus I squared, which is negative 4 plus 1, which is negative 3. Oops, minus 1. Come on, erase. Minus 1. It's like whenever I make a mistake, it wants to just keep it there to punish me. All right, so negative 5. 3 minus 5 is negative 2. And then this is a nice distributing, so that would be negative 4 plus, and then we put negative 2I, just so that we have it. So bringing that down, we have negative, oops, it's positive 4. And don't worry, if you make a mistake here, it's going to check very quickly on the next part, minus 2I. And then we just have one last step. And we already know that this should come out to be 10 because it's a 0. So all we have to do, if everything worked correctly, is that 2 plus I times the 4 minus 2I should come out to be 10. If it didn't, we made a mistake. So 2 times 4 is 8 minus 4I plus 4I. That looks good because those cancel. And then that would come out to be minus 2I squared, which turns into a positive 2. And there it is. Checks. Checks perfectly. All right, this is the hard part that was done. This now from here on out, it's nice and easy. So the second part, we're now using the conjugate, and we already know that at the very end, we should also get 0. So everything here should work out perfectly, and it will, watch. So we bring down the 1, and so 2 minus I gives us 2 minus I, and those give us 0. See, all of these are going to come out to be rational, real numbers because we don't have any imaginary coefficients up here, right? These are all real coefficients. Nice rational numbers. All right, so you can even have irrational, but if they were irrational, we'd know we'd have an irrational 0. That's another story. Okay, so going back, they're all nice real coefficients, and so we should end up with real coefficients here. So everything here is going to cancel nicely. So we get 2 minus I cancels. This times this is 0. So we end up with negative 2. And then distributing that, we get negative 4 plus 2I. And that gives us 0. And that's what we were looking for. We needed that as 0. And so what are we left with now? We're left with our nice quadratic. So that's x squared minus 2. So to find our 0, we just set this equal to 0. So x squared equals 2. Bring it over here. Square root, x equals plus or minus radical 2. So those are the other ones. And you're thinking, well, there's no radicals in the problem because we have their conjugate. You have a positive and a negative. So our zeros are negative radical 2, 2 minus I, and 2 plus I. And that is how you find your zeros. So the whole idea of each of these problems is to take a 0 that you know, break it down with synthetic division to a quadratic, and then use quadratic formula or factoring to find the other ones. So watch, we could do this with another one. We already knew that 1 is a 0, right? So if we took 1 and we went into it 1, -2, -5, and 6. Using synthetic, we get 1. That's 1. That's -1. That's 1. -1. That's -6. And that's -6. So see, there it is. It's a 0. So this is now the quadratic that we are left with. So if I set that equal to 0 and I factor it, you notice the other two appear. That 3 that we started with is now one of the zeros we get at the end. So that's x equals 3, x equals -2, and then finally also x equals 1. So our zeros are again -2, 1, and 3. It doesn't matter which one you use. So if I did this again and I put -2 here, it's going to break it down into a quadratic that has -3 and -1 in it. It doesn't matter. You just need a 0 to get it started, to get it down to that quadratic. And then you can factor it or use quadratic formula to answer it. And if it looks like this, you use square root property. Thank you.